Hey everybody, today we're going to begin the Polygons unit. For most of the kids who have me normally, this is going to be fresh air. It's finally something that doesn't only involve triangles. So I'm hoping that people will get a lot out of it, and we'll get started and try to crank it out as quick as we can here. All right, so we know that the sum of all of the angles in a triangle is 180 degrees no matter what. We did that so many times in the last chapter that it should be pretty much drilled into your brain. Now, as far as a rectangle is concerned, you see now a polygon, basically now we're talking about any of these figures. It could have 3 sides, 4 sides, 20 sides. It doesn't really matter. When we're dealing with figuring out how many degrees are in a rectangle, that should pretty much be common sense here, because now you've got 4 right angles. So 90, 90, 90, 90. So if you have 4 right angles, 90 times 4 is 360 degrees. All right, now, just to be a little bit crazier, let's mix it up a little bit. What about a hexagon? If we use the same logic that we just got done using for rectangles, we could probably actually draw it out pretty easily and figure out what we're doing here. So what I'm going to do here is I'm going to take our rectangle from before, and I'm going to turn it into a hexagon. Okay. Now, the reason I'm doing that is because you can start making a good guess just by the information we have here. So what we have here is a hexagon, and we made it up with a rectangle and with 2 triangles. The sum of all of the interior angles in a triangle is 180 degrees. So that's 180, and that's 180. Now, we also knew the rectangle was 360. So it's not a coincidence. If you want to know how many degrees total are inside a hexagon, you could take 180 plus 180 plus 360. You end up getting 720 degrees. So what we've actually created here is a pattern. You know, we could say 3, 4. I'll leave 5 blank for now, but we'll get there. We know that a triangle, anything with 3 sides, has 180 degrees inside of it. We know that 4 sides, that would be like a rectangle, that'd be 360. And it turns out, by the way, that's true for any quadrilateral, not just rectangles. Anything with 4 sides, it fits. All right, so we've got 720 here. So if we actually look at the pattern, it goes up by 180. That means if the next one were to go up by 180, that would be for a pentagon, that would be with 5 sides. 180 plus 360 would be 540. It turns out that pattern is actually true. It works for every polygon if we're trying to figure out all of the interior angles. If we want to figure out what they add up to, the sum of the interior angles. The pattern is it just goes up by 180 every time, starting with a triangle that has 3 sides. You cannot go lower than 3 because it would no longer be a polygon. All right. So we can turn this into a formula that doesn't really surprise anyone. That is the theorem we're going to work with here is the Polygon angle sum theorem. And we're going to turn it into a formula so that people can apply it to any figure, no matter how many sides we have. The sum of the measures of the interior angles of A, and this is where we're going to get into a strange phrase here. We're just going to say in-gon. Now, here's why I bring that up. There is a certain point where instead of naming things like triangle or hexagon or pentagon, there is a certain point where we pretty much give up. Now, by the way, 4 sides, we would just call it a quadrilateral. I know a lot of people are thinking that I was going to say square or rectangle. Quadrilateral is anything with 4 sides. The reason I'm using the phrase "in-gon" is that there is eventually a point where we just don't want to memorize all of the names. Like, let's say we were dealing with a 25-sided figure. Instead of trying to remember what name a 25-sided figure has, we would just call it a 25-gon. That's kind of our way of saying that's it. There are only so many that we're ever going to remember, so let's just cut to the chase. All right, now the formula for it, the sum of the measures of an in-gon, and so I want you to write real quick, a polygon with n sides. That's a good way to remember it. That's a good official definition. And here's the formula. n minus 2 times 180. That's it. One of the easiest formulas we do all year. You take the number of sides, you take away 2, and then you multiply by 180. Now, quick note, n has to be greater than 2. It's like I said, you can't have a polygon with 2 or less sides. You have to have at least 3. Triangle is the lowest you can go. All right, let's do some practice problems and see what this looks like. What is the sum of the interior angle measures of a heptagon? So one of the things I tried to do in this note sheet is introduce you to some words that you might not be terribly familiar with. So we're going to start with heptagon. You know pentagon, you know hexagon. Heptagon is after that, so it's going to be 7 sides. All right, so if you wanted to use the formula for the sum, you would do n minus 2 times 180. In this case, n is 7, so I'm just going to plug in 7. 7 minus 2 is inside the parentheses, so you're going to get 5 times 180. And that pretty much tells you all you need to know. 5 times 180 will give you the answer, which in this case is going to be 900 degrees. So if you were to draw a 7-sided figure and you were to take all of the interior angle measures and add them up, you would get 900 degrees. All right, let's try this again, but we're going to use 19 instead. All right, so 19 minus 2 is going to be 17 times 180. So in this case, you might want to use a calculator, although you're watching a video with me, so you can probably just guess that I'm going to tell you soon enough. If you were to look at a 19-sided figure, you would end up getting 3,040 degrees inside of the thing. That is a pretty ridiculous number here. All right. Example number 3. Now we're going to get a little bit tougher here. I am thinking of a polygon with interior angles adding up to 1,080 degrees. What is it? So the difference here for example number 3 is that this time you know what the sum of the interior angles is going to be. Your job is to go backwards and solve for n, so that you can figure out what kind of figure it is. So they're not telling you in this time, but what they are telling you is that when you're all done, it should add up to 1,080 degrees. So we're going to take our formula and we're going to put it equal to 1,080. Now at this point, it's going to be a 2-step equation. The first thing I'm going to do is just divide both sides by 180, because I've got that right here, I've got that right here. All right, there you go. So when you do that, that gets rid of the 180, and you end up getting n minus 2 equals 6. Now that doesn't actually tell me anything yet, because I'm going to have to actually add 2 to both sides to finish this thing up, which means n equals 8. Now, I guess that would be an okay answer, but I'm not really cool with it. I think we can do better, because it didn't say how many sides does it have. It says what is it. So you should probably give me the name. And so you should know that if you have a figure and it has 8 sides, it is called an octagon. That's the answer I was really looking for that question, was octagon. So I know you don't know every name, and that's something that's going to come in time, but I think octagons are something you should probably know pretty well. All right, so example 4 is probably going to be the toughest one here because the setup is going to be different from the others. So pay close attention if you haven't been up to this point. Example 4 is definitely going to be the hardest one. I am thinking of a regular polygon where every interior angle is 108 degrees. How many sides does it have? So once again, we talked about how you can just set up the formula. You know, you get your n minus 2 times 180 formula. Now here's the catch. How many degrees total would be in this figure? Well, we don't know. All I know is that there are 108 degrees in each angle. I don't know how many angles there are, but I can use common sense. I can think back to our last chapter here. A triangle has 3 sides. It also has 3 angles. 1, 2, 3. A rectangle has 4 sides. It also has 4 angles. So if I took that 108, because I know every angle is 108, and I multiplied it by however many angles there are, I should get the number I'm looking for. And since it has n sides, that means it also has n angles. Okay, so that is the secret to figuring out example 4. Once you get to that point, it's actually just algebra, but I'm just showing you that's what you should expect out of this problem. And I do like this kind of problem, and I would bet when we take a quiz over this chapter, it will be there. So 180n minus 360, that was just me distributing, equals 108n. Now from here, there are a couple different things you could do. In this case, I'm going to just subtract the 180n from both sides because I already have a number on the left, so I might as well just move the variables to the right. Okay. Now, one of the secrets for you knowing whether you did this problem correctly or not, your answer cannot be a decimal. When we're talking about trying to figure out how many sides are in a figure, you can't have half a side. You can't solve and be like, well, n equals 9.6. You can't draw a figure with 9.6 sides. So you will know you did it right, and I know I ran out of room here, but that's all right. You will know you did it right if you get a natural number for n. That means a positive number. No decimals, no fractions, a positive number that is 3 or higher. In this case, a negative divided by a negative is a positive, and 72 goes into 365 times. So the question was, how many sides does it have? The answer is 5 sides. All right, 2 more things before we quit here. Example 5, solve for x. You're going to get a lot of these. When you get a problem like this, all you really have to do is add up everything you know and take it away from your goal total. So in this case, it has 5 sides. It is a pentagon, which means my goal, my total number, is going to be 540. This whole thing should add up to 540 put together. So if you look at all of those angles on the inside, when you add them together, which in this case you are going to get 91 plus 118 plus 118 plus 91, you end up getting 418 degrees, and then you've got that x. Put together, they should add up to 540. So all you really need to do here, not a huge deal, subtract 418 from both sides, and you should find out that x, and it makes sense because if you look, that angle did look pretty obtuse to me. X equals 122 degrees. All right, so the last theorem, the easiest theorem possibly in the history of this class. All right, so pay close attention. This is the Polygon exterior angle sum theorem. Now, I briefly talked about exterior angles in a previous lesson. I'll get to it here in a second, but just let me write the theorem itself. The sum of the measures of the exterior angles. So again, I'll show you what an exterior angle is here in a second. Of a polygon, one at each vertex, is always 360 degrees. It's crazy to think it's always 360, no matter what. So let me show you what an exterior angle is real quick, and I can actually use the picture from example number 5 to demonstrate it. If you take one of the sides, and it doesn't matter which one, but if you take one of the sides and you extend it longer than it really is, what you create is an exterior angle. That right there is an exterior angle. So if you look down on the bottom, like I could just give you another example here. If you took this side and you just extended it farther than it actually is, what you have created right here is an exterior angle. And what this theorem is telling you is that if you were to add up every single last exterior angle, one at each vertex, you will always get 360. It is a guarantee. So when you look at example number 6, what is the sum of the exterior angles of a triangle? Well, it's going to be 360 degrees. All right, what about a quadrilateral? That would be a four-sided figure. Well, it didn't actually matter. 360 degrees. A pentagon, 360 degrees. I think you know where we're going here. A dodecagon. Now, you might not even know what a dodecagon is. It's got 12 sides. That's the deal. But it didn't actually matter for the sake of what we are doing here because it's 360 degrees again. How about an icosagon? I'm just throwing words out there just to see if you get the point. By the way, that one's 20 sides because I know a lot of you are going to hear that and going to be like, well, what is it? It didn't actually matter because the answer was still 360 degrees. All right, so I'm looking forward to having a chapter where we're not dealing with just triangles. I hope you are too, and I'll see you next time.